Alright, so let's learn about jittering with data analysis. Say we had an Excel spreadsheet and it was about data from student course evaluations for college courses. And a common question that we ask on student course evaluations is, number one, what grade are you expecting to receive in this course? And students will often be given options that rank from 0 to 4, 0 being an F and 4 being an A. And then another question commonly asked is, overall, how would you rate the course instructor? Or in this case, how much do you agree or disagree with the following statement? Overall, I rate the course instructor very highly. And then the answer sets would range on a 7-point scale from 1, very much disagree, to 7, very much agree. And so if we had 50 students in a class and they all participated and all completed this course evaluation, we might get an answer set that looks kind of like this one. So we got 50 results here. And so if we created a scatter plot to show a correlation between the expected grade that students are going to receive and their rating of an instructor, that correlation, that scatter plot would look kind of like this. And while you can see there is a relationship, a positive relationship between the expected course grade and how highly an instructor is rated, the problem with representing our data like this is that we're really only looking at about 12 to 15 pieces of data here. You can't really see all 50 cases, and the reason for that is because of the limitations of our scales. You can only answer on a 0 through 4 scale here, so there's 5 options, and then you can only answer on a 1 through 7 scale there, so there's 7 options. So there's really only 35 total places where data could fall in this. And if there's any kind of a correlation, especially if it's tight, you're really not going to be able to see very much of that data. And so this really gives kind of a limited view. So the usefulness for jittering is actually creating variance in your data, so they don't all stack on top of each other like this. And so you can see all of your data sets in your visual representation. And so if we took all of our data from these first 2 columns and copied them over to a second set of columns and relabeled our variables as jittered for both of them, V1j and V2j, and we added little bits of random decimals, positive and negative to each of them, they would look something kind of like this. So you can see we've added 0.06 to this 2 right here. And we've added 0.077 to this 3 right here. And we've subtracted away 0.21 whatever from this 4 right here. So all of these little bits of variance that we added and subtracted from all these numbers over here end up creating this new data set that won't stack up on top of itself and allows us to see all 50 cases of data and get a more meaningful picture of what the relationship is. So now we're going to go through a quick example of how to do this, and then we're going to plot that sample down here. So say again we kept one of our original questions, what grade is a student expecting in the course, but we looked at a different question. Instead of variable 2, let's look at variable 3, which is a common question. Would you recommend this course to others? And in this case, how much do you agree or disagree that you would recommend this course to others? And the answer set ranges from 1 to 7, 1 very much disagree, and 7 very much agree. And so if we took this data set and we plotted it on a scatter plot, it would create this this representation right here. And so we have the same problem we had with the first set. Too many of them are stacking on top of each other. It doesn't really look meaningful. So we're going to jitter this data right now. And the way we're going to do that, we're going to click on our new columns that we've created here, and we're going to type equals, and then we're going to type the cell that we're referencing, that is the data we want to jitter. So in this case we want to jitter the data from right here. So I'm going to type E4, and then we want to add our random variance. So we're going to add to it, and now you're going to hit 2 parentheses and type rand, R-A-N-D, followed by an open parenthesis and a close parenthesis. Now what that does, if you put an open and closed parenthesis after a rand, the rand function, it generates a random value between 0 and 1. And So that's going to average, that variance is going to average around 0.5. So we don't want to just be adding little bits of variance to them. We also want to subtract little bits of variance. So we need to shift that average of 0.5 back down to 0, so that way some of the variance being added will actually be negative and will take away values. So let's go ahead and shift it back down by subtracting 0.5 from where that random value is going to average at between 0 and 1. And then finally, we might be adding really big pieces of variance to our data. So our new average is going to be about 0.25, but that might be positive or negative. But the absolute value of our new average is going to be about 0.25. And that's kind of adding a good bit of variance to things. That might throw things off too much. If you look at our scale here, we're not really dealing with a big scale, and so throwing things off a whole quarter of the way on average might disrupt it too much. So I'm going to multiply it by a half, by 0.5. So now we're really halving the total amount of variance that we're adding and subtracting to everything. So now the average absolute value of the variance we'll be adding and subtracting would average around 0.125 instead of 0.25. And now we're going to put a closed parenthesis, and there's the end, and now we hit enter. And so what that just did, ignore all the little shifts that you see here. Every time you add a new value to Excel, it's going to recalculate the random variance. But that's irrelevant. That's just going to keep shifting. So yeah, it subtracted about 0.19 from this value right here. And so we're going to duplicate this over to here, and then see how it shifted everything again. All these values shifted when I made a change, and now drop it down, and now they shifted again. And now let's go ahead and insert a scatter plot of this jitter data. There we go. And let me make a few little modifications that I like to. Copy this, paste it here. And oh well. So anyway, I like to make these hollow so that way you can see all the data sets, but that can be in a different video. But anyway, you see here, this is the same data that we were dealing with up here, except now everything's been jittered with this random variance we created, and now you can actually see the majority of the data sets. Maybe not quite all of them, because some of them might be kind of stacked, but yeah, this shows a much better visual representation of the positive relationship between expected course grade and the course whether or not you'd recommend this course to another person. So again, yeah, that's jittering, and all you do to jitter your data is you reference the cell that you want to jitter, you add to it a random value between 0 and 1, you shift that random value down a half, so that way it averages as 0 instead of a half, and then you weight it by whatever weight you want. I decided to reduce it, and I weighted it by a half so that the variance wasn't so powerful, and this was enough variance to accomplish what we needed. So that's jittering. Hope that helped. Alright, thanks.